Yeah, start the recording.
It's getting recorded. Yeah. Okay. Yeah. Yeah, I think I have to go through. Yeah. So this ugly number is given. We have to find their factors are 2, 3, and 5 only. Those are the prime factors it should contain. And for 6, we can see 2 and 3. Similarly for 8 and so on. Yeah. So anybody wants to share some approach or code in this?
Yeah, on a high level, what I am thinking is maybe since these are the factors are prime numbers, right?
Yeah.
So there is no overlap among 2, 3, and 5. So for example, if I get a number and I can divide that number by 2, that means that I am not taking anything away for 3 and 5. Basically, if I can divide the number by 2, I can go ahead and divide it by 2 and see what is left, and see the left out part can be divided further by 2 or 3 or 5.
Yeah.
Because generally we might get concerned that if I divide it by 2, and if there is something else down the line in the factors list which I could have divided by, that problem doesn't exist here because the factors are prime numbers. So maybe I'll just iterate the number, see what I can divide it by, 2, 3, or 5, and as soon as I can divide it by any of them, I'll divide. If I can't, then it doesn't exist. Maybe the answer doesn't exist.
Yeah. Makes sense.
So Bhumik, when you're saying like they are not overlapping like 2, 3, and 5. So what if they were overlapping? Like if we had numbers to be divided by 2, 6, and 5, then that would be a DP solution?
Don't know. That would be a
Okay.
harder one than this one.
Okay.
But yeah, in that case, we'll have to definitely think, because see, if I have 2 and 6 in my bucket, then if I divide the number by 6, then I used 2 and 3. So maybe I would in that case also divide all the factors or break all the factors into the prime parts, and
Okay.
then maybe take it from there, just to avoid or minimize the overlapping.
Yep. No problem. Thank you.
Yeah. Thanks, Mom. So just same approach what Bhumik said just now, that we'll check by dividing first by 2, and we check if as long as the remainder of this is not 0, keep on dividing, and the moment you hit 1, it'll return true and false whenever you have, and the number is less than 0, return false. The same approach Bhumik, whatever he said.
Yep.
Any queries in this, or we can?
For the dividing by 2, right?
Yeah.
In spite of like running in a while loop, we can normally check n in n and n minus 1. So that will reduce a bit of time, the running time. We have the property to check power of 2, right? And let's suppose n number and number minus 1. So once you are done,
Let's say n is 6.
Let's Okay. So if you can go and like first what you will do, you will run this 3 and 5. This loop first you will run. Like after whatever remainder left after dividing by 3 and dividing by 5, right? Let's suppose 6. So you first we will run by 3. Okay. Take another number. Let's take 7.
Okay. You want to share your screen? Or?
Yeah, sure.
Okay, yeah, that will be far better, I think.
I just connected now, so just give me a bit of time.
Yeah, sure.
Can you guys see my screen?
Yeah.
Okay, so actually I did it yesterday. Can you just tell me the problem name once? I mean,
Ugly number.
ugly number, right?
Yeah.
Just start typing over there in search box, it will appear.
Yeah.
If you had already opened it.
Yeah.
Yeah, so if you see here, this is what I did. So I'm first checking for all the threes, like let's suppose any number, uh, be it 11 maybe. So first I'm going and checking for this thing, your divisor of mod 3 is equal to 0 or not. Okay.
So it will go to the return statement directly, right? 11 and 10, because none of them
Yeah.
will be equal to 11
Right.
and 10.
Yeah, right. So once you, if this condition is coming as true, I mean, this will come as false, right?
Here and is bitwise ending you are doing, right?
Yeah, bitwise ending.
Okay. So
Yeah.
11 I think will be 11 will be 1011.
Yes. And 10
And
will be
10 will
1011. 1010.
1010. So
Right.
one,
So once you do the end, so we'll find that a 1 is remaining at the end.
yeah, I
1011
think
and like it will be 1011 and 1010, right? If you do a logical AND,
it will be 10, I think.
10, right? So that means that uh, we cannot divide this number by 2 or 3 or 5 as the question demanded.
Why you didn't check with 2? Like
So
you had
see, yeah, so for 2 you are doing the same thing, right? Dividing it, first checking the modulo and then dividing it by 2 again and again. So this thing just does in one line. You don't have to run a while loop again. Let's suppose it's a very big number, so you can directly check with one of this thing statement. So basically what dividing by 2 means, right? 2 is uh, 2 to the power 1 is 2 and then 4. So if some number is divisible by 2, that means that it has to be some power of 2.
yeah.
So let's suppose 8. Okay, so 8 is 1000, and we will check with 7 0111, right? Now in this case you'll find that the answer is coming as 0.
Yeah.
So that means that that number is divisible by 2.
Yeah, that is a smart way actually. You are saving the 3 iterations of while loop here.
Yeah.
Yeah, but actually, I don't think that will make very significant difference in runtime, because only there are log n numbers which are power of 2, right? So
no, the iterations are not saved because he is dividing already by 3 and 5. So if it is 11, you are already dividing by 5.
Yeah, but whatever will
No,
be
but
left will
yeah,
be
the
either power of 2 or so
power of
after
2.
you are dividing by 3 and 5.
Yeah.
Yeah.
okay.
So 11 won't be get divided. Like you cannot divide 11 by 5 or 3, right? Because the modulo will not come as 0.
Right.
That's
So we
right, yeah.
directly, So directly go in this condition. Now you don't have to run for so many times. You just check once and then return.
So how did you get this intuition?
So if you see that there's a bit manipulation, there are many, like I've read this article somewhere. So I remember that. So see, whenever we are having a number, right? Let's suppose 0010, 0011, 3, and then it is 4, and this is 5. So every time within these numbers you see like only one you see a 1 bit of 1 changing. right?
The last
So
bit, okay.
last bit, yeah. So let's suppose this is 6 and this
It's not
is
6, I think.
7. Sorry, 7, and then
Oh.
this is 8.
Mm.
So whenever you get to a point where you have a power of like you are having a power of 2 and a number just before it, so you can see that, I mean, there is a this difference is always there in any case. So using this intuition only I did.
Very nice.
Yeah,
No,
that's a
it's
good
good one.
approach. Yeah, a different one.
Bit.
Now, can this problem can, I mean, I know we are doing in iteration, but how do we do it in recursive? That's also possible, right? We could do recursive. Anybody has done that?
Yeah, why
That
why
would
why
be
you
a
want
good
to
way
do
to do it.
recursive when the iteration is so
Yeah, simple.
I mean, we are just learning it. I know this is the better approach, but I'm just curious if anybody has done that.
instead of while loop, just replace with a while with a recursive.
Yeah, just like in this while loop you can directly, I guess, just return num by 3, right? I'm not wrong. How can we write this?
What do you want to write?
Like you want to recursive, yeah, recursive call to see that if so there will be a condition.
Yeah, we need to
or
write
should
a
Have to
base.
have a base condition, yeah.
Base
Yeah, that is
condition is
okay.
here. Num is less than
Yeah,
0. I think num
less
by
than
3 or num by 5.
or right.
Either of the case, if it divides, then
Yeah, I think something like this will do your
by
yeah,
okay.
might be.
No, but the problem will be here. Like, let's say if a number is 14, if you divide number by 2, then 7 will come, and 7 is not a, I mean, it's a prime, but this is not included in the list of prime.
Yeah.
So that can create, again, you have to check something like whenever you divide this number by 2, whatever you are getting the quotient, that shouldn't be, and that should be in the list of this 2, 3, and 5, right?
Yeah. Yeah. Okay.
It's not.
I joined late. Can you explain the number 7? What exactly do? And also, why are we not doing with number 2?
Number 2, I didn't get you.
You need to check with number 2, 3, 5, right? Why are we not checking with number 2?
Oh.
So for because if you see, right, whenever this is where I've represented this thing. So whenever there is a power of 2, so only the leftmost, there will be only the leftmost bit will be 1. Like let's suppose it's 2, so 1 0, or then it is 4 1 0 0 and 8 1 0 0, and the number preceding to it, okay, will contain, like here if you see, this is 7, so and this is 8. Okay, so if we do a logical AND between these two, so you'll always get 0 if that number is a multiple of 2. So using that property we are doing this num and num minus 1 equal to 0.
Okay, num and num minus 1.
Yeah, so let's suppose we got 8 in this
Okay.
question. Yeah, so 8 mod 3 is not equal to 0. 8 mod 5 is not equal to 0. So directly if you again run a while loop, you check num mod 2 not equal to 0 and you wanted to divide it always. So in spite of that, what we are doing, we are just checking return 8 and 7, doing a logical and checking that if the answer is equal to 0 or not. In case if it is 0, we are returning true, else we are returning false.
Okay, so
Yes.
So 7 become true now here, 0 now. Yeah.
So what num and num minus 1 does is basically it removes the rightmost bit, right? And if it's only a divisible by 2, so it means it should be a power of 2. now because we have done with 3 and 5, right? And a power of 2 means only one bit is set, right? And if we remove that rightmost bit, the number should become 0. And so that's why it's working. That's my assumption. That's my understanding of this problem.
Yeah, I think it checked if like that's the whole number, there's only one bit set.
Exactly.
Right.
Exactly.
So if we have multiple bit set, and then if we minus 1, the the leading bit is still on, but when we end it, then it's not going to be equal 0.
Yes, exactly.
So if it's only one bit set, it's the power of 2, and power of 2 is it have to be r divisible by 2.
Yep. And it will work for 1 as well, because for 1 also it is
0,
but 1 is a valid number, right? Because 1 typically means that it is a correct one, right?
Somebody there is a chat somebody posted this link. It's very nicely explained. Thank you, Simar.
Yeah, it's a good works for beginners as well, so you can use that.
If this works for like num is in base 2, so it works like that, then if we convert the num in base 3 and base 5, then we can do this in O of 1, right?
I don't think so. You can do that for
because like now num we convert into binary representation, so there will be only one set bit representing it's a 2 power something. So we do n9 n minus 1 equal to 0. That means it's
but do you think that it will take time to convert the num from binary from base 2 to base 3 and base 2 to, like, basically the decimal to 3 and decimal?
3 base and 5 base.
Yes. So it will take some time, right?
That's again a
I think that would be like, okay, maybe.
But if 1 also work, and it wrong, right? Because if we do the last operation on line 7, and suppose at that time the num is 1, then if we do that operation, then it's going to be return true, but 1 is not divisible by 2.
So 1 and 0, 1 and 0 will not be equal to 0, right?
But when you add that we're going to be equal 0, right?
1 and 0 is 0.
Yeah, sorry. Right. Yeah.
So I thought that 1 is a valid answer, no?
Yeah, 1 will be starting from 2, right? They're asking us to check from 2, 3, and 5. So 1 and 0 should be a valid answer.
Yeah, so 1 and 0, if you add, it will be 0. So he's comparing 0 with 0. So it is right.
Why is 1 and 0 a valid answer? Because 1 cannot be divided by 2. Can it?
No,
1 by 2 is 0.5.
If you look at the notes in this
note section, they have mentioned like 1 is
a valid one.
Okay,
and
maybe
0
that's
0 is not valid.
Yeah, given 1 is
1 is an ugly number, that is what it says.
Yeah, so maybe we just put an if condition that if it is less than or equal to 1, we return true, because I would not like assume that I can divide 1 by 2. 1 by 2 is not even an integer.
0.
Yeah, maybe a base case, something like that.
Yeah.
Actually, they are also giving a negative number, right? So you have to check in the way that if num equal to 1, then return true. Only that condition. Stopping the share.
How would the negative work? Because at the end we need the answer to be 1, right? After all the divisions. Then if I have a negative 8, for example, after dividing it by 2, my final answer would be -1. I would never be able to get 1 for a negative number.
So it's a sign bit. As per my understanding, you have a plus on the leftmost bit, right, for a sign integer.
So, but the negative should be actually the best way to do is we'll convert into positive and then work on it.
Absolute value taken then at last.
Yeah, just take an absolute.
ABS.
That is what I think. Because if you keep on dividing negative numbers by all these factors, it will be slightly. Yeah, it should work though, right? Yeah. Because it is working here in his case as well as Shashank, whatever is implementation. In both cases, it's working. So the sign should not matter.
Input 32 bits identity.
Could we take a small example of let's say -8 and see if it worked?
Yeah, sure.
Yeah, in his case might not, but Shashank's case may.
There it will return false itself there only. -8 is less than 0, it will be false.
Okay.
Yeah.
Yeah, because he is returning that. Okay.
Yeah.
But it should not be false, right?
Why? Because even if you take -8, its prime factors will be 2 in. Oh, no. No, but they are telling something. It should not be false, right?
It should not be false. So in
No,
your
they are
case,
telling that only +2, +3, and +5 should be there. So 8 will be written as what? -2 into -2 into 2 into 3 minus will be there. No, -2 into -2 into -2, because after our resultant product is -8, right? So all these factors are containing -2, -2, -2, but they are telling that it should be strictly +2, +3, and +5.
Yeah, you need at least one odd minus factor.
Yeah.
Okay. Yeah. I'm sorry. Yeah.
Sorry, I didn't get that. Can you repeat that?
The -8 can be written as -2 into -2 into -2, right? Those are the three prime factors for -8. And they are telling that only prime factors should be +2, 3, and 5.
Okay.
So it contradicts with the condition.
There's a reason, I guess, the dislikes are more on this question because of this confusion, I guess.
So -8 actually converted to 2's complement, and num -1 actually when it will be -7's 2's complement, right? So therefore they cancel. Yeah. It's correct.
Yeah, we can switch to next. Yeah, so pancake sorting. So we are given an array A. We can perform a pancake flip. We need to choose some positive integer k such that k will be less than the array length. Then reverse the first k elements of A. Reverse the order of the first k elements of A. We want to perform 0 or more pancake flips, doing them one after the other in succession to sort the array. Okay. Now we need to return the k values corresponding to the sequence of pancake flips that sort A, and any valued answer that sorts the array within 10 raised to the power array of length. 10 into array of length. Flip would be just the correct. Okay. So this is the input given to us. So this is how they are flipping it. So first they took the entire k equal to 4, started from there, flip the entire, so it will be 1 4 2 3, then k equal to 2, so they reverse the order. This 1 4 became 4 1, then again they flipped the entire one, it became 3 2 1 4, and again first 3 they have flipped, and finally it's sorted. The moment it's sorted, so they have recorded 4 2 4 3. This is the answer. And in this case it's already sorted, we don't need to flip anything. And yeah, the constraints are like length should be less than 100, and AI is the permutation of all these numbers, 1 to 8 at length.
What is the last one? Last flip?
Pardon? Which one?
Last flip. When fourth flip. K equal to 3.
3. What they are flipping this portion. 3 to 1 is flipped as 1 to 3.
Okay.
Which is again sorted 1 2 3 4.
Is that the answer? I think 4 2 4 3, right?
Yeah, 4 2 4 3 is the answer. 4243.
Oh, to sort it out.
Okay. Yeah. Yeah, any queries or approaches on this? Anyone?
But this is not the normal pancake sorting, right? So
Yeah.
in a normal pancake sorting, I would go is find the highest number first and then flip from there. Starting with the 0th index, right? And then put that, because that will come on the 0th index, and put that back in its right place, and then keep on continuing. So if you look at these numbers, what they have got, they are good. They are very optimal numbers, like 4243. So I didn't understand this sorting, how they have done it. Means, yeah, I can understand here, but programmatically, I don't know how to implement it.
Yeah, that also is correct answer, because that's what I have done and it passes. So they say they are saying that there can be multiple of these answers.
Yeah.
So all you need to do is sort it somewhere in the form of a pancake, and in the end it should be less than some. They mentioned something about the question. Can you scroll it down?
For example, 1. What did you get as a result?
1, 0.
Or 1.
Like empty, because it's already sorted, right?
Which one?
No.
This one you're talking, or
example 1?
Oh, example 1. I see.
Okay.
So what you will do initially you will try to bring the 1 to the first. Location, right? So it means that you have to pancake a 4, correct?
Yeah.
4 is correct. After it is done, then it will become 4, 1, 2, 3, right? Then you will try to bring. Oh no, but you should try to take the last number to the end, not the first number. Am I right?
Okay, so
and then reduce the pancake size.
Got it. I kind of did different way. I did with first flip 2, then 3, then 4.
I see.
And then it kind of goes a different direction, not as this, but it still gives a positive answer.
Okay. No one to share?
But yeah.
Okay.
1 second. You see my screen?
Oh, yeah.
Yeah, so let me see. So I took, for when the case 2, it goes 2, 3, 4, 1. Case 3, 4, 2, 3, 1. Case 4, 1, 4, 2, 3. Now from 2, 3, 4, 1, we can either go in the same direction, which is gonna give us the same here, but we're not going that way. So we kind of not take K2 in this case. So K3 is 4, 3, 2, 1. K4 is 1, 4, 3, 2. Now when we take same here, we don't take K2 and 3, we take 4. So it's 1, 2, 3, 4. That's how we go. So the path is gonna be 2, 3, 4. So yeah, that was my intuition. Like, and you're saying that first in pancake flip, we're trying to get the last one in its place, right? So first we have to do 4, and then we have to do 2, right? 4 and then 2. So it's included in this case. But I took like the shortest, I mean the least amounts of flips in this case.
I didn't get your solution. Can you please explain once again?
Yeah. So for, let's say this array is actually hold on 1 second.
I think he's trying all the possible solution and flipping with 2, 3, 4, all the numbers present in the array.
So initially we have 4 choices, right?
Yeah.
Yeah.
So we're flipping starting from 2 to the length of the array. Okay. So we're trying all possible flips. We're starting with 2, and then we take out 2 out of the picture when we visit 2. We take 3, and then we take 3 out of the picture when we visit. And so on and so on. So the first time you encounter a sorted array, that's when you return it. That's when you return this path. 2, 3, and 4. Is that clear? The way, I mean,
Yeah,
So
that's
time
thinking goes.
complexity here would be exponential, right?
Say it again.
Tree,
Time complexity
he's
here would be
he's
exponential.
doing like he's doing more of a BFS. So as soon as the
height into number of nodes, I think, of each at each level.
Yes.
Well, the thing is here is we're not visiting these. I'm sorry. Let me just 1 second. So it's not confusing. We're not visiting 2 again in this case.
Okay.
And here we're not visiting K2, so we're not visiting these.
Okay.
And so this the same case. Here we're only visiting. Hold on. My pen.
So in each level, you'll have n-1 nodes, right? Worst case, I'm talking, huh?
Yeah. Each level is gonna be n-1.
n-1 into height.
But wouldn't this happen that if we found answer at say rightmost path, then we would have to still traverse the entire left part, right?
Say it again. So if it's 4, can you give me an example?
So, so like I think k equal to 4, but you are down the line, you are again visiting 4, right? So it would be at any level, it would be the 2 to n-1 minus the k what was operated before. So you are not visiting 2, and so I don't know. It's kind of hard for me to.
Okay.
On the left tree, you are doing k equal to 2. In the next iteration, you are not visiting 2. But on the next one, you need to visit 2. There is a possibility that you may, like just how if you go to right tree from the root, you have k equal to 4, then you do k equal to 2, and then you are again doing k equal to 4.
Okay.
Yeah, that's true. Okay, so I think in that case we can actually, there is a limit here. It says 10 times a in a dot length. So in that case, we can visit 2, and down the line again 2, 2, 2, and when it reaches 10 times a length, then we return back without result. I'm sorry.
Yeah,
I got
right. Yeah.
I went the wrong way. So yes, okay, we visit case 2. And we visit also here, all three here. So when we get to...
No, the immediate node you don't need to visit, otherwise it would be same flip.
Yes, that's what I'm saying. I mean, but like we have to iterate through all of them, right?
But you can avoid going through the one which already you,
so kind of check if it's the same as the original one?
Right, previous one, yeah. Because then it is the same number, you're flipping it again, it doesn't make sense.
Got it, yeah, I know.
How do we estimate the runtime of this?
Oh, well, let's see.
I think the nodes at each level and whatever the worst case height of the tree would be.
Yeah,
the height.
Yeah, so it would be n-1 to the power of 10 because we can go only 10 level deep.
Yeah.
So as per what Darshan was saying, like if you have in the first one when k is equal to 2, the branch, actually you should not do it, right?
Which branch?
The first one, k is equal to 2, when it starts from the first one, because 2 is already in its place, no?
No, what I'm saying is, so on the starting from root, if you do k equal to 2, right? So you flip 3 and 2. In the next level also, if you do k equal to 2, then you again flip 2 and 3, which is the same as then on next level, like third level, your answer will be same as root.
These are
That's
equal.
what I meant. Yeah, exactly.
That will, by that way, we can prune it, right? We can memorize that, keep track of that, which we have already visited.
Yeah, we can do
that.
that.
Yeah, something like that we need to do.
Otherwise, I think it will hit TLE in that case.
Or the other option is like we can still allow this, but we can terminate when it goes into 10 times, like because our tree is so we can keep track of how many iterations it did, and if it is doing like 10 times, then we terminate it.
Yeah, I did that approach. I mean, it might not be the most optimized, but I check here that when it's greater than a.length at times 10, return false.
Okay.
Any other approach or anything? Any other kind of like point of view of how to solve this?
I'll share it. Let me see.
So you at every level you did. How do you like compare if you got answer? You need to check the sorted, right? Is sorted or something? Yeah.
Yeah, I have a method is sorted. So I take I kind of optimize of all of ends, like n over 2. I take both ends, and first I check if the left one is greater than the right one, false. Otherwise, first I check if they're not on the edges. If they're not, then I compare if the previous one was less than the left one. I mean, the previous of left is greater than left, or previous of right is less than right, and then I return false in that case. Otherwise, if all passes, it's true.
You can just maintain a number, the sorted order, and then just compare the number directly.
Yeah, that would be a better approach.
Say it again. How?
So you should maintain that 1, 2, 3, 4 is your desired answer, right? You can.
Oh yes. Yeah, I went that way too, and I just kept the Okay.
So that, or you could this approach is good, but I think we are not capitalizing on localization of reference. So when you have too large of an array, then you are accessing the first number and the last number, which may not be in the memory. So I think it would be better if we can just do O of n, which is like just compare next number if it is greater than the current one.
Yeah, so the constant for the problem is that the length for the array is 100.
Yeah, less than
Yeah.
And the number are between 1 to 100 only.
Would the same memory if we convert it to a string and then sort that?
So another constant for this problem is that the numbers are actually the permutation.
But with the string, we can do permutation too, right?
Yep.
So Leon, you are saying convert this into a string, the input?
Yeah, I don't know if it's same memory.
No, actually, but the problem statement talks about pancake sorting. So we have to do some way the pancake sorting way, right?
Yeah, so my intuition was that so when I solved this problem, so considering the fact that when we have to do the k sorting, so we have to do only the first k element only, right? So I cannot fix the position for the first element. I cannot start sorting from the front, because every time I will have to sort it, it will actually change the value for the already sorted element. So I start sorting from the back. So first I try to find that, okay, whether my last element is in place or not, considering the fact it's a permutation and length is 100. So at last position, the value should be 100, right? Or whatever the length is of the array. If it's 10, so last value should be 10.
Okay.
Yep. Yeah, so I check that if it's not the last value is not at the correct position, then find where is my last value.
Index you'll get.
Yeah, index for the last value, and then
do 2 flips.
Yes, so do 2 flips. Yes, the first with that, and then the length of, or the what is the last position I'm going to fix here. 2 flip and sort the array, and then do repeatedly do the same thing.
Okay, so first you said you find the element.
No, first check the last element or whatever element position I'm going to fix, right?
Okay.
Find that whether that position, the last or that element is at correct place or not. If it's not correct place, then find where is the correct element exists in the array.
And when you find that particular index, so you look for the right and left elements and swap them, right?
No, just I have to look on the left because the right element from the right it's already sorted.
Could you share screen?
Yeah, share.
Yeah.
Oh yeah. Do you guys see my screen?
Yeah.
Yeah, so you guys can see that. So here, first I'm checking that whether my last position, which I'm going to fix, is at the correct place or not. If it's not, then find where is the correct element exists, the index for that element. And add that index position in the flip array, right? The return array. And then flip the array around that, and then put the second element in the flip array, because now I want to move the fixed element from that first position to the last position which I'm trying to fix, right?
Yeah.
So the moment you find that index of that particular element, you'll kick out in the next round. The array size will be shortened, right?
Yes. So I'm trying to fix. So here in this case, so my answer will be, so let's take that input. So if I take that input 3, 2, 4, 1. Okay. Here I know that my last element should be 4, right?
Yeah.
So now I know that it's not at correct place. So I find the index for the 4. Where's the 4? 4 is at 3, right? So I find the index, and let's say this is my output array. So I put the value 3 in the output array, and now flip the array. So it will be 4, 2, 3, 1, right? After flipping.
I think 1 should be, okay, go ahead.
No, 1 will be as, now I know that my last index which I'm trying to fix is at the first place. So I will flip again with 4. So now it will be 1, 2, 3, 4. Is that? Yeah.
1, 3, 2, 4.
1, 3, 2, 4. Yeah.
Oh, sorry, 1, 3, 2, 4. Yes, that's why I was saying that. I mean, 1, 3, 2, 4. Right. Now I know that this is at the correct place. So now I'll try to fix this index. Right. So this is at correct place. So now my array size is now 3 character, right? Or three element in the array. So 2 is not at the correct place. So now I'll repeat the same thing. I'll find the correct index. Where is the 3? 3 is at 2 place. So I need to flip these 2 elements. So I'll put here 2 and flip here 3, 1, 2, and 4 will be here. And now I have to flip these. So now I have to flip again 3. So that will be 2, 1, and now 3 and 4 are at correct place. So now I have to check that whether this is at correct place or not. No. Then I'll find the correct position and flip again.
So what would be the time complexity then?
So the time complexity for this will be because
order of n only.
If it's in the wrong position, so to put it in the right position, you flip at most 2 times, right?
Yes.
I think it will be almost O(n) square, right?
Yep, that is true.
Yeah.
Because this is more like similar to a selection sort, right?
Yeah.
That you always try to fix a position to a particular element, which it should be open square.
Yeah. But Praveen, actually, the way you did is a classic pancake sorting. But what Martino was explaining, he was getting actually the way they are getting the output, which is an optimized answer. Because he's trying to do all the combinations and getting the least one.
Right.
Yeah.
Yeah.
Yeah, I would actually go with this way because it's slightly better to understand. But yeah, Martino's way would be the most optimum to implement.
I'm missing the point. How would that be more optimal?
No, not more optimal,
Answer
but the
wise.
shortest, but the shortest
Yeah.
one. You can say.
Yeah, time wise, I'm not sure how much it is going to be.
Okay, I see. So it may be able to give a result which would eventually be optimal, but the process would be time consuming.
Yeah, maybe. Yeah, that's true.
No, Martin's one is like a DFS. It may not be optimal. That's what I think.
Suppose that the array is sorted in reverse way. If we do the Martino way, it's gonna take a while, right? Because it finally go to the right branch. It flip out once, but if we do this way, we only flip it once.
That's right. Yeah. This is more optimized way, I guess.
Yeah, but the answer you don't get it the way they are shown,
Yeah, I think the whole thing is not about the time complexity when he's saying optimal. He's saying in terms of the shortest number of steps.
Yeah.
So that's what he's trying to say. So for example, in this case, our answer will contain five steps, but here it is actually 4 in the answer.
4. Yeah.
So that's what he's saying. That's all.
Also, I had one question. The way that Martin's algorithm worked, that was backtracking, right? We were trying different choices of K and arriving at the solution.
No, we are not removing anything out of it. It's kind of backtracking, but not exactly backtracking. In backtracking, you decrease the length of array each time. I mean, you do something and you kick out the element from the array. So you are not kind of exhaustively searching all the possible paths, but exactly you can't say it as a backtracking. Kind of.
Okay. Okay, because you even if we consider it to be a DFS and we go deeper down a branch or so it will take exponential time that way. That's
I thought he was trying to do BFS, not DFS, because as soon as he gets the answer, he just returns it, right?
Yeah, but actually the clue that gives out is DFS is that you are going down the tree. For example, when K is 2, you're going all the way down, and then when you hit 10 times array length, then you return back.
Yeah, you're right.
And so on and so on.
Yeah, it is DFS.
DFS, yes,
and terminating at 10 level.
Yeah. So I think this way, Praveen's way, it's gonna be less steps and probably faster.
Did you both guys submit and see what the statistics are?
Yeah, let me see.
Oh, yeah,
I'll do it
so
again.
I submitted
should work,
that.
yeah. It will.
I don't know how to check.
Yes, 4 milliseconds, right? So almost.
Yeah,
like this one.
Wait, I made something. I got something wrong, so I think I modified something. Never mind. So
no problem. So Martin, when you are done, can you at least share your code whenever possible?
Yeah.
On the Slack channel.
Yeah, no problem. Yeah.
Thank you.
And Martin, what was your intuition to actually go with that? So how did you actually decided, okay, I'm going to solve the problem in this way?
Well, I saw that. So when I saw the description, First of all, I saw that we need to flip kind of like a prefix flip. So I didn't know how they started with 4 and then go to 2 and then 3. So I kind of started with, okay, let me first try flip 2 and then check if it's sorted. And then 2, I'll do 3 now, and then and so on and so on. So I kind of came to this drawing this tree. So that's how my intuition went. So I went from 2 to all the way to the length to kind of flip him for every way. Yeah, but I guess it's not the most optimized way. There's
No, that's fine. I just want to, understand that how actually the intuition came that, because in my case, that came from the constraint only. I was not able to actually, when I looked their example, I was clueless that how to start.
Yeah. So I was too. So I started. So I draw the elements 3 to 4 1, and then I saw, okay, what happens if I flip 2? Or what happens if I flip 3? And what happens if I flip 4? So I kind of draw them out and started drawing for each level like that, K2, 3, 4, and so on and so on. So yeah, that's how I started.
Okay.
Yeah, maybe looking at the output, then you start thinking something different.
Yeah.
Okay. So I'm stopping and to you, Shashank. Sure.
Yeah. Yeah, we can proceed to next. What I mean, it's similar to Praveen, only what I did simply I was removing the element at one step. That's it. Again, like what I did is I had this array 3, 2, 4, 1. So I started from the back, and I'll try to try to check for the largest number, because whatever the indices of the array is, that will only be the numbers present in your array, because they are saying that this is the permutation of all these numbers only. So I'll check first for what is the correct position for 4. So this is 3. So I'll flip elements across 4. So what I'll do, 1 I'll put this side, and 3, 2 I'll put that side, and whichever correct element was there, that I'll kick out of the array. Next time I'll search for 3 and flip it like 2 this side and 1 this side, and 3 I'll kick out. Next time 2, I'll have 1, and the moment I reach empty, I'll get the, I'll exit out of the loop.
Yeah.
And this is what I'll be appending the number 4 number along with the indices in the flip array.
Yep.
No.
It's good.
It's very, very clean.
Yeah, it's very clean, very small.
So in this case, for runtime complexity, each flip is count as constant time, or each flip is count as the number of element that we need to flip.
It depends on number of elements, right? How many elements you have on left and right.
Okay.
So I'm not good at Python. Can you please walk me through again a little bit?
Sure. So I started from the back of the array. This is the last, the extreme size of the entire size of the array. I'll go till the index 1, because when you put 0 means it won't go to 0, one element greater than this, because backside we are reversing. It will go up to 1, and by decreasing a size by 1, this -1 stands for that. So what will happen? Let's say first time 4, the size of this array is 4. I'll pick the index of that element, because 4 should be present at the last of your array, right? If you want to make it sorted, 4 should be present at the last. So I'll pick the index of 4 first. So when I pick the index of 4, I'll see 4's index is 3. And now what you'll do, you pick these many elements. This is for the swapping step. You'll pick elements up to this index, up to this 4th index, put it to the take it in a separate array, and this in a separate array, and then concatenate those two again. Like first we'll flip it like 3 and 2. You will have 3 and 2, and the first one will be your 1, because it is from this index, whichever index you are getting for 3, and up to -1. So this one will come in the first part, and your 3, 2 will go to the last part, and we are concatenating them.
So if the number is in the correct position, statement on line number 8 does not matter.
Yeah, in that case, it won't matter.
Okay.
But that this doesn't sound like the step that they are explaining, right? Like you are just so from the element that you are searching, you are splitting that array into 3 parts: the current searching current element, left side and right side, and then you are concatenating left side and right side.
Right side, yeah.
So it's not really the steps that they are explaining, right? It's a little different.
No, the intuition that Praveen said, no, that why we are going from the back side, that matches. After that, it's a bit different from him. Little bit minor modification is there.
So it's not the pancake sorting. Yeah. Okay.
Yeah, it's not pancake sorting. Yeah. Okay.
So this flips dot extend. What does this, so index? So first time you will get the index as 3. So this one is going to add 3 plus 1, so 4. And what is comma n?
And this will add the number, the size. N was the size of the 4. I mean, at what position? From last we are starting, no. So that will be the first 4th index.
Oh, so you are maintaining 2 values in here, like.
So I think this is very much similar to what Praveen was explaining.
Yeah, it's
it is actually the same thing. It in a very well optimized way. So Shashank, it would be helpful if you can break this down into the internal steps. Right, 3, 2, 4, 1. You found out that you need to flip from 3. So the intermediate step would be 4, 2, 3, 1. And then you'll again flip from 1 because you want the 4 to come back to the end. So that is how you are doing on line number 8. I think that would be more useful for people to understand.
I think, I mean, it's doing the same thing, just the language actually doing the magic here.
Yeah, I think.
Yeah.
This is the extended that will have.
So, but at each step, instead of doing 2 flips, he's doing a single flip, but adding 2 numbers there.
Yeah, I mean, it's not it's flip, but output is you see that 3, 4, but you see the only one line. In one line, he's actually appending the values.
Right.
At line number 8 in his code, so he's appending 2 index.
Yeah.
Yep, and I think one of the reasons for this efficiency, as Shashank mentioned, right, that he is using the property of permutations. That is, if there are I elements in the array, then all of them are going to be distinct and all of them are going to be from 1 to I.
Yeah,
that property is really playing the efficiency
crucial role here.
Good. Yeah, let's move on.
Yeah. So this is the longest duplicate substring here. So string S is given. We need to consider all the duplicated substrings, which substrings are hidden in the substring S in nature. Substring such as substring of S that occur 2 or more, the occurrences may overlap. Okay, and you need to return any duplicated substring that is the long.
Shashank, you are not sharing the proper screen.
Looks like we lost him.
Yeah, I think he will be coming back. Is it not?
Yeah, am I audible?
Yeah. We
Yeah,
lost
I
you
think
for some time. Yeah, it's okay.
yeah, sorry for that. I think I have to record it, right? Okay.
No, it's recording.
Okay. Yeah. So like banana is given, you can say that ANA is repeating, and what they are saying, the occurrences overlap. So ANA, and again this A is overlapping and ANA, and here none of them are repeating, and these are the constant length should be less than 10 raised to power 5, and it will consist only of lower English letters. Yeah. Okay. Yeah. Any approach or queries in this? Let's start with brute force only first.
Yeah, so brute force, what you would actually divide each and every this big string into smaller substrings, and then find out if there are duplicates, right?
And longest you have to check which one is the longest substring which is repeating.
Okay.
Yeah.
So maybe you start from the back side, like if it is the length is n, you start from n minus 1. And then you say if there are two strings, if not, then keep on decreasing.
Yeah.
So whenever you find, actually you keep on decreasing. When you don't find, you just go back to the previous index and then you return that string.
Yeah, that's good. So I think it will be like around order of n cube, right? Because n square it will take to generate all the possible substrings from back, and the order of n for checking which one is the longest.
Yeah.
So
I think,
overall,
I think the same thing we can like pick up n to generate all the substring and sort it, and then probably we.
So if you sorted, that substring property would be law, or sorting by what, lengthwise?
No, sorted by. No, I mean, like, if the first one we the first string be banana, the second string would be begin at the second character, so A N A, right, and the third one will be N A, and then we generate on that substring, and we sort it, and then walk through it and look for the common one.
Yeah, actually. So in that case, we can compare the two strings which are consecutive strings.
Yeah.
And then whenever we find, whichever is minimal one, which a common one, then you just give that string, return that string.
And somebody was mentioning in chat suffix tree, if you can explain. I think his name is like Puneet. Yeah. If he wants to explain that suffix tree.
Yeah, so the property of suffix tree is that will consider all your substrings when you're creating the suffix tree. So what you will do is you will create a trie-like structure and start from the first string, like banana. And then what you'll do is you'll just take up each of the substring, but it should be a suffix. Like first will be banana, next will be ANA, and that way you will be able to create a trie from all the suffixes. And the one, wherever you see a duplicate, what will happen is, let's assume the first one, banana. So when you're creating ANA, you will have something, a path in the trie. And when you're inserting ANA, you will already, traverse a path which is already created. So while you are creating that suffix tree, you will be able to find out which, substring you'll be able to accommodate with already existing path. And at that time only, while creating the suffix tree, you can find out which is the maximum, longest duplicate string in the entire substring. So I'm not actually right now in front of a machine. I could have shared it, but if someone can share, I can,
Yeah. Time complexity would be n square, right?
Yeah, that will be, the time complexity will be the creation of the suffix tree, which is n square.
Yeah.
But that space at the cost of space. What was that? I think it will be at the so try will have some extra spaces will take, right?
Yeah.
Yes, it will take some extra space, but it will reduce your time complexity from n cube that we're discussing for the first to n square.
Yeah.
So Puneet, did you try that problem with suffix tree and submitted that? Because considering the length for the string 10 to the power 5.
Yeah, submission would be possible. I guess he was just sharing the approach because n square solution would work as per the constraints.
No,
so actually what will happen is the size of the suffix tree will actually not be that huge if you have repeated strings. Right?
No,
if you don't have,
size of the suffix tree is not the concern, but when you generate the suffix tree, that itself takes O of n square, right?
Yes.
So as per the constraint, it's the maximum length of the string can be 10 raised to 5. So 10 raised to 5 raised to square would be around 10 raised to 10, which will not work, right?
I have not actually submitted it. It's just an approach, which I had in mind. I have not submitted this one.
Okay.
Excuse me, can you explain how it's n square? I think it should be n cube because you have to take I and j index and you have to generate substring, which will itself take O of n.
So you don't have to take all the substrings. You just have to take suffixes. So all the strings ending at the last one and starting at any intermediate point.
Okay, fine. So you are taking the jth index as always n minus 1, right?
Yes.
Okay, fine.
So you start at the ingesting into try from banana, and then next ingestion would be ANNA.
Right.
And then the next wait is NANA.
Exactly.
And then if you find ANA again, so that means it is okay.
So that's actually the property of suffix tree. It actually, when you're traversing a suffix tree, it covers all the substrings. All the intermediate nodes where there's more than one, it is actually a substring of the string.
Okay. It's a good fact actually. I was not aware of this.
I'll share there's a good actually a course on just suffix tree. It's a part of a course just on suffix tree. It's a really nice course if you want to understand suffix tree. I'll share it on the Slack also.
Please share that.
But in this case, the length of the input would affect the size of the try, right?
Yes.
So if it's 10 to the power of 5, then that would be a lot.
That would be, yes.
Yeah, but I thought someone say if the repeating character is not going to be
yeah, if they are repeating character, it will not be exactly proportional to the size of the string, or n raised to r2, it will not be that much. But if you have everything distinct, yes, it's gonna take up a huge space. It's n square space also.
So even if you have let's say I have an input string of A, then I still need to create 3 levels for the try.
Yeah.
So the space is gonna be the same.
Yeah, but the size of the try will just be first full length. It will not be n squared. It will just be n, because when you're traversing the substring, like suppose you have 3 A's and then you are traveling 2 A's, those A's are already created, right? From the first string. You just are traversing a path in the try, and if you reach an end, you just mark that node as, let's say, it's a leaf node. It's also
right. But we're talking about the size of the try. So the longer the string, the bigger the size of the try. So would that run out memory?
I will have to check. That's as I said. I have not tried it. This
So
was
the
just an approach that
depth of the try would be the size of the word, the maximum depth, and the width of the tree, a try tree would be the unique characters in the word. That would be a width at given level.
Yeah, but anyway, we will have to do the same thing for the one what we were talking about, right? So anyway, we'll have to find all the string combinations.
Is the brute force getting accepted in the OJ? I'm not trying.
No.
No brute force.
Brute force not at all.
It will
Actually, even if you go with the binary search and even I think the suffix way doesn't. It is a very different way of getting accepted. You need to use some hash functions.
Yeah, it's
And do
something
all that
like
stuff. Yeah.
I read in the discussion that people are talking about rolling hash.
Right.
Yeah.
Rolling hash actually will work.
And binary search also.
We're trying to create a rolling hash for all the lengths, and then just compare. If the rolling hash is matching. Is that what they're doing?
Yeah, I did not try to read the full discussion or full article, but
Yeah, rolling hash.
was
They'll try to create first rolling hash for the pattern. Let's say whatever. Let's say you want to match ANA within the string. Okay, so you'll try to first take all the substrings with the binary search, create the rolling function for it, and check the rolling function of this matches with which part of the string. Let's say if the length both matches, and try to match each of the character whether they are same or not. If they are same, then you got that substring. If they are not same, then you try for the next. I think
I did
show
not
you an
get where they are
example.
using binary search.
Yeah, binary search, there is a property like, let's say if I give you a string of length, what do you say? If I give you a and is repeating here, right? With a as overlapping, right?
Oh, okay, so they are saying if you are able to match a string of 4 characters, you will definitely be able to match a string of 3 characters.
Exactly.
Yeah.
Less than 3. It can be 3 too. Yeah.
Yeah, that's a good approach.
Yeah. And
Could
then
you
we are using.
explain the binary search again? How it work?
It's like, let's see, banana is given to you, BANA. I think it's correct, right? BANA, it's correct. Let's say here the string which is replicating is ANA is replicating, right? So what you can see, if ANA has to replicate, it's a string of length 3, then all the string which are less than length of 3. So less than length of 3 will be what? A and AN. So A and AN will also replicate, since a string of length 3, this entire string is replicating. Because how will you get next time ANA? Definitely the A has to repeat, AN has to repeat, then only this entire string will replicate for the next time.
Yeah. So what he's trying to do in a binary search is taking the string length and then dividing it into, and then you divide into 2 and then take the lowest part, right? If you don't find a match.
Match, yeah.
Yeah.
And then you keep on going it that way. If you find a match, then I'm going to come back, come to the right side.
Yeah.
And you will
To
find
check
off
the
your one. Yeah.
Exactly.
But for searching and actually comparing whether that is a duplicate one, you need to use the rolling hash.
Rolling hash, no. Rolling hash is like, see, I can give you, let's say if you have this
rolling hash thing.
Yeah, sure, I can. Sorry, where is that? Let's say this is your text. Okay, this is your text and this is your pattern. So first you encode this pattern. Once you encode it, so A will be given position of 1, like ORD of A minus A, that relative encoding you do. ORD of A minus A, you'll do, it will be equal to 1. Similarly, you do for everything. So you'll have one for this, and B will have a 2. Now they have told you that you'll have only lowercase English letters. So there are 26 characters in this. So, and the reason behind using this big prime number is that to avoid the collision in the hashing, that I'll show you. Let's say let's say simple simple hashing function I'm using, that I'll club all the values of this. Corresponding to A you have 1, again here you have 1, again corresponding to B you have 2. So total is what? 4. Sum total is 4. Additive approach I'm using. Now you search for that 4. You start from this and search when you get a 4. So when you club A, and B, you'll have a hash function will match with it. 4 and 4 will match. Now once 4 and 4 will match, you'll start comparing the characters. You'll see whether A matches with B, but it is not. Since it doesn't matches with it, then you'll remove this character, this A you'll remove and include the next A. So this 2 you'll subtract from 4. So it will be 2. It will be 2, and then you add this to this. What is next A is there? It will again be 4. So when you are hitting 4 here, right? So when again your hash function matches with this part of the substring ABA, again you'll start comparing whether A matches with B. Again you see that no, it's not matching. So again you'll remove this character and take B double A. So what's the problem is here I'm using additive approach, a very normal way of hashing. So when you are using normal way of hashing, many number of times you are getting the same 4, 4, 4. So that is a collision. Your average time you are not able to reduce it. So we need to take a largest prime number. Sure, go ahead.
Yeah. So why the prime number? Like why we cannot take bigger prime number of the same range, similar magnitude?
So actually this BA is one of the input, right, to the search function.
Yeah.
So because he's doing a binary search, so he came to some number, like maybe the half number of the string half. And then you can actually vary the string length, right?
No,
so but he's just trying to show an example what happens in the search function.
No. Actually, I think maybe I didn't communicate my question very well. So what I was saying is for calculating hash of the string, we take some prime number, right?
Yeah.
So the number has to be bigger. That part I understood, but why it has to be the prime number?
There's a property for prime. See why it has to be prime number, right?
Yeah.
I think there is some proof for that. Exactly. I don't. Yeah, that's a good question. Like why it's a prime number?
Yeah. 10 raised to 9 plus 7, something like that.
The prime number generally.
Oh, that number actually is the mod number, right? Actually, it is for integer overflow.
That is integer, but why only prime factor? I mean, prime number we are taking. I think the reason is the prime factor will have only 2 factor, 1 and the number itself, right?
So because that is the biggest prime number, I would say, for an integer. And that is what the number is.
Okay.
For your integer, which is 32 bit, you can have that is the maximum prime number.
Prime number.
Okay. Yeah. I got that. That's the biggest prime number, but that's 10 raised to 9 plus 7, right? So why we can't take say 10 raised to 9 plus 8?
Because if the string is bigger, you need to have a very good hash function. So if it's like the string has someone said about AAA, like 10 raised to 5 or whatever it is, then that would be a better way of doing it, because you will get most of the combinations possible, because it will be like A and then it's a single B there. To find that uniqueness, you will have to do that.
Okay.
That is what my understanding. Maybe I'm not very sure, but looking at that big prime number, I think that makes slightly more sense.
Okay.
No, one reason you told that's correct. Like integer overflow, it will also take care of.
Yeah.
Okay.
Second, I also don't know what is reason behind using. One reason I saw that to avoid it. I mean, if I would have used the normal one, many number of times you'll repeat the same hash number, right? So that is hitting your collision. But if you take the extreme one, the chances of hitting the collision will be reduced.
Yeah, in the rare case, corner case.
Fine. I think we can move ahead.
It's the same thing. Like so I took that. What do you say? This is the rolling hash function. Like I took the bit with what I'm representing. There are 26 letters raised to the power 0. This is the hash function that I've designed for the pattern. So I generated encodings for this, and this is the entire hash function for this particular pattern BA. You take the number, take the mod of it, add the subsequent number, and again take the entire mod with P, and again add this next number and take the entire mod with P. And similarly, you generate for this and just check whenever your this hash value matches with any of the part of the string, you just start comparing whether that character matches or not. If the first character itself doesn't match, then you need to subsequently move to the next and kick out the first one, and so on. So actually the time complexity with this and the brute force, like normal, when you do if you want to do normally, like you want to check this pattern in this, both will be same only. Order of mn, it will be order length of string into length of the pattern, but average time I think will be less in this case. The average time will be less. That's why I think we are using this rolling hash function. Or if somebody has some other reason.
I'll explain. I don't know how to implement it, but I can explain.
Yeah, sure. Go ahead.
So, what we will do is, no, I think, you can actually share. I'll share my screen.
Oh.
Share screen. So, share. So what we do is, say we have array, say up to this part we have gotten string, hash of string is h1, then h2, then h3, then h3, then h4, then h5. Say we have a string of say a, b, c, d, and e. I'm just explaining that rolling hash part. Why is it working? Yeah. So then what we will do? So basically, these are the hashes of the prefixes. So for example, the prefix ending at 2, its hash we are saying is h3. Then for the string which is ending at 3, we are saying its hash is h4. So what we do is, say if I have gotten say L equal to 2 in my binary search, then what I will do, there is some mathematical formula to calculate hash of any substring in this string. So that's something like prefix of for say if you want to calculate hash of say I to j, then it's something like prefix of j minus prefix of I minus 1, something like that. They do some inverse modulo and those things. So what you do is, as you go along, so you keep saving this part into a one hash set or something, and as soon as you see this part repeat again, so you will know that this string I have already encountered in the past. So this is my answer for this particular length. The answer is possible. Does it make any sense?
Yeah, actually, yeah, you're right. So because you have to save that in the hash set, so next time you hit on it, you get that.
Yeah. So it will become, so in linear time, you will be able to determine whether particular string, the repetition of particular length is possible or not, and log L for binary search. So your overall time complexity will become L log L.
Yeah.
So on line number 10, we do the prefix hash, prefix sum of hash, right?
Yeah, hash of prefix.
Okay. But then even if they're the same, like Sachin explained, we still need to go to that string and compare one by one.
Yeah, so for example, say if I want to check for a string of length L2 whether their repetition is possible or not. So what I will do, say this is my set. So first first possible string will be h1 comma h2, right? So I know that the hash of h1 comma h2 is say some value, say a, or let's better call it h2 minus h1. h2 minus h1. Sorry, actually it will be h2 only. Yeah. Then hash of the substring h2 h3 will be h3 minus h1. Then hash of substring h3 h4 will be h4 minus h2. So what I'm saying is, say if I again encounter this similar hash h4 minus h2, it may happen in computation, right? That h4 minus h2 I again encounter. Then that's essentially a point when I will say that I have already found this substring. So I have already repeated. So repetition of this length is possible.
This minus is basically for removing the first character only, right?
No, not just first character. Not just first character. Basically, so when you are calculating hash of say h3, h4, then you have to return the hash of reduce hash of entire h1, h2, right? So that's why h3 minus. That's why we are doing h4 minus h2.
Okay.
Yeah. So first you need to create an hash. In a hash set, you need to create this row length hash for the given string, and then you have to go through each and every string in the bigger string, and you have to find hash set for each and every substring, and then you look in that hash set. So then it should work. Yeah.
Yeah.
Do we need to keep like have a map and say, okay, this substring right here is correspond to this hash, or we just use the?
No, we don't have to have a hash map for that.
You just use a hash set. See, actually, you can just use a hash set with strings. That will actually work if we don't have these complications everywhere, right? Because in the normal longest substring, whatever the normal problem is, so there you don't need to keep all the hash functions, right?
Yeah, but that way your complexity will increase now, because every time you will iterate this, you will have to generate substring of that particular length.
Right. So, but in this case, we have to do it because this problem is slightly different.
Okay.
Yeah,
fine.
that is what I'm trying to say. Therefore, this hash set and all this complication about the rolling hash comes into picture.
Okay, I got it. Okay, so anyone is taking over?
Yes, Shashank.
Yeah, it's the same.
So basically, if anyone knows that how that inverse modulo thing actually works in calculation, then it would be really helpful. I think they must be doing it somewhere. Yes, I think in this part.
Shashank implemented that, right?
Yeah. If you can, I can share the screen.
Yeah, mine did not work at all. Yeah, so I got some errors.
If you stop sharing screen,
Is that
bit right? Okay.
Stop sharing. Yeah.
Yeah. So what I did, like, first this is the binary search that I used. No doubt here, right? Any doubt in this portion? Here, the base condition is that the moment you have only one letter left, then that's a base condition for this binary search when we'll exit out of the loop.
Yeah.
So any query in this?
No, that's fine. Yeah.
Okay. Yeah. Now after that, here comes the main. So the base 26 letters you have. This is the prime number that we have taken. Now this is the exactly formula that you're using. Max base, we are deciding like how function pass the base, what length of the entire string, and this prime, whatever we are doing. Now what we'll do, let's say you took the mid of a string and you passed it lower half. What do you say? Like in dup string, you are passing the lower. We calculate the middle of the string and passing the lower half. So for every character here, we are designing this hash map, and I've created and then corresponding to that hash as a key, I'm appending the length of a string. Now what I'll do, I'll go through the index and the character of it to the from right half will go, left half will leave, and from right half will go, and in every step I'll delete the first character, take the first character out of it, and did this like get the ASCII value and multiply it with the max base. The max base is this function that I've generated. And similarly, just will check if that is present in the hash to index table, whatever we have created. We'll take that particular substring out of it, and then what we'll do, we'll check whether if it is corresponding to that, we'll get a key, and we'll check if this length is equal to the substring that we have passed If it matches, then you return that particular substring, else you append the index of it. And else, if in the worst, and if you don't have that, then just
yeah, anyway you have to append it, right? Yeah.
Yeah, I think if if your hash is not present in this,
insert into that, right?
Okay, yeah. And then at last, if none of them you found, just return the empty. I think this we need to know the formula for this, and this the process is like you take every character from that string and then convert it to the ASCII, multiply it with the max base whatever you have, and then after that normal it's like put it, check in the hash if it is present, and then get the substring out of it.
Shashank, actually I didn't understand that part. Is where is that missing, or we don't need to do that at all? So when I was explaining, I was mentioning now that we will have to calculate something like prefix sum.
I didn't do that way. If you have,
then how are you calculating hash for some any substring?
Yeah, that is what I told you here. This formula I'm using. The Robin-Karp algorithm is the standard algorithm itself. So how I'm doing is, where is that pattern? This is the string, right? I told you I'll take the first. I took the corresponding to every. I'll generate first numbers 1, 1, and 2, and then whatever the base is, the same formula, whatever base. I've taken this, add with the next one, and take the modulus of everything, and again add this one and take the modulus of for the entire thing. So it's different, I think, bit from there.
It's using the 26 base, right, instead of 10
exactly.
base. Yeah.
I think yours was mentioned in there, like.
Yeah, but actually I didn't understand that part.
Okay.
Yeah, the second approach is slightly difficult to understand. The first, at least, is can understand that, because the second part, when you're comparing, you're just using a sliding window, right?
Yeah.
For me, didn't compile. I didn't actually pursue and debug it, but no, it compiled, but it was not giving the right results.
Yeah, I have a general question that how you guys get the intuition that you can use rolling hash here. Like sometimes it gets difficult to identify that we can. So yeah, if you guys can help me.
Okay. So I think actually if you don't know rolling hash algorithm upfront, then I think it will be hard for you to realize that you can apply rolling hash here. So I think for this kind of very special algorithms, if you have known it and have solved a couple of problems on it, then I think you will only be able to realize.
Okay. You need to know the string matching algorithm, like KMP we could have also used here.
Okay. Okay, and what's the intuition behind choosing the hash function, like that we can like use different hash functions? So how do you guys decide that we can use this particular hash function?
So actually this is very standard hash function, like it's actually very mathematical, so no one will be know every no and hows of it, but I'll share one article with you in which it's very well explained. So it's an article by CP Algorithms. It's a very well-known site for competitive coding. So it's very excellently explained over there. Of course, its mathematical proofs are not covered, but you will get a fair idea.
Okay, fine.
Yeah,
just to add it to that,
developing such intuition is not easy. I think we have solved it earlier, or we know those algorithms then only.
Yeah, otherwise, whenever you find something very different, you would like to go inside it and find out what it is, So that is what I would always do, and then try to learn something different.
One small, see what Santosh was saying, that this process, like you'll generate all the substrings and then check for the longest. So what you could have done, if you can reduce this, like searching part, that will be that using binary search. That also concept is new. I mean, until and unless we don't know that length of if you have a length of 3 or any length n and any length less than n, if you can use binary search in that, because that will again replicate. So that will reduce time to log, and this will remain same, but average time will be reduced when you use Rabin-Karp or KMP, like.
Yeah, in my case, as I was not aware about the rolling hash. So the intuition was that considering the constraint here 10 to the power 5, so and other constant that 2 or more, the duplicate string, substring. So my intuition was that, okay, if it's duplicate, and what is the maximum substring, possible substring from that is n by 2, right?
Yeah.
So I started from there. So I started checking that whether I do have a substring for n by 2. If I don't have, then check for n by 4 using the binary search. And if I found that n by 4, then look somewhere in between.
Yeah. Yep, no problem. I think that's.
Yeah.
You can stop the.
Oh, this. Okay. Yeah.
Yeah, he's sharing this, right? This thing actually.
Yeah. Yeah.
It's long recording that. Yeah. So did you stop the recording?
I think, yeah.
No, it's still, I can see it's recording.
Still recording.
Disable or this only, no? Please request. No, actually that time, the moment when I came out, no, that time only recording stopped there.
No, it is still recording.
But here is saying please request recording. Host is Praveen, I think. He has the right to stop.
Oh, Praveen, can you stop that?
I'm the host now?
Yeah, you are the host. Someone made you the host. Yeah.
Surprise host. Let me, how can I, okay,
You
pause.
go to the record and then stop there. Yeah. Or maybe don't stop.
Okay, yes.